So in the previous lesson, we talked about equivalent resistance, calculating it for a pure series circuit and for a pure parallel circuit. So in this lesson, I'm going to show you an example for when you have a mixed circuit. So first of all, there's something like an order of operations. When doing this, just like doing regular arithmetic, you have to do brackets first and exponents, division, multiplication, addition, subtraction, and follow BEDMAS. I mean, there's not an acronym for doing equivalent resistance, but I tried to outline the order of how you should be doing things. So step one, combine any loads together that do not have any junctions between them using the equivalent resistance formula for series circuits. So you scan the circuit and you look for places where you've got two or more loads pretty much right next to each other with no junctions in between them. Okay, so they're on the same string, basically the same wire. So you look for all of those and you just add those up using the series formula, which is just regular addition. Okay. Then once you've done that, you redraw the circuit, replacing the loads that you just combined together with a single equivalent resistor. So if you took two light bulb resistances that are right beside each other and you added them together in series to get like a total resistance, then you need to redraw the circuit, replacing those two light bulbs with one resistor and label it with the new resistance you found. Then step three, then you look for parallel parts. Okay, so you look for strands that are basically parallel to each other. And you're going to use the equivalent resistance formula for parallel circuits, combine together loads in parallel that are not separated by any other loads in series. Okay, so you have to look for strands that are purely in parallel with each other with no extra loads in between, kind of screwing it up. I might be able to show you what I mean in this example. Once again, after you've done that, you redraw the circuit, replacing any loads you combine together, replace them with just one single resistor. And then repeat steps 1 to 4 over and over again until a single equivalent resistance is determined. So you go through this process. As you go through this process, your circuit should shrink. Okay, as you redraw your circuit, it gets smaller and smaller and smaller until you're left with just one single resistor. We'll call that the equivalent resistance. So I'm going to try to show you that with this example right here. So I've got a circuit that I've not connected yet to the battery. So the battery is 19 volts and the current is unknown right now because it's not connected yet. So I've got a 10 ohm bulb at the top, and then I've got a 15 ohm resistor along with a 10 ohm light bulb on my outside pathway of this parallel circuit. And then I've got another pathway where there's a 20 ohm light bulb. So that's a mixed circuit. So there's 4 loads here, and I need to shrink this circuit down step by step, smaller and smaller, until I'm down to one single equivalent resistor. So I'm going to make a second video, which I'll write out the math steps more using the math format, and I'll show you how to redraw the circuits after each step. It's kind of hard to show that just with the PowerPoint slideshow. But I did try to describe the mathematical steps in words to somehow get an answer. So the first step is to add any loads that are not separated by any junctions. Add any loads that are not separated by any junctions. So that would be the 15 ohm resistor and this 10 ohm light bulb on to the right. There's two 10 ohm light bulbs, so it's this one here on the right and this 15 ohm resistor. There's no junctions separating them. There's no place for the path to split in between these two. So we just add these two together using the series formula, which is regular addition. So 15 plus 10 is 25, and that's what I wrote here for step 1. Okay, so these two together make 25 ohms. Then I look for parallel pathways and combine them together. So I'm going to take the 25 ohms that I just calculated. That's one pathway. That's in parallel to this 20 ohm light bulb pathway. Okay, so I've got two pathways in parallel. So I'll combine them using the parallel formula. So that's the one with the reciprocals. Okay, so I have to do 1 over 20 plus 1 over 25. I add them together, get a common denominator and all that. That adds up to 9 over 100. And then I have to take the reciprocal of that. I'll show you the steps in the next video. But the reciprocal of 9 over 100 is 100 over 9, which is what I wrote for the answer for step 2. 100 divided by 9 is 11.1 repeated, if you like decimals. So up to this point, so at the end of step 2, what I've done is I've actually combined these 3 loads. Okay, these 3 loads are now all combined, and these 3 loads in total make 11.1 ohms. Then I go back to step 1, and I realize that this 10 ohm bulb is in series with this 11.1 ohm chunk. So I just add 10 to 11.1, and yet that gets me an answer of 21.1 ohms. And that's the equivalent resistance for this circuit. So once again, I'll show you this a second time in a second video where I actually write out the mathematical steps and redraw the circuit after each step. So the equivalent resistance is 21.1 ohms. So then that's how much resistance this 19 volt battery is going to have to go up against. So here's just a calculation for the current through the battery. I take the it's Ohm's law, voltage divided by resistance. So take the 19 volts divided by the 21.1 ohms, and that should give me a current of 0.9 amps. And I went ahead and built this in the circuit construction kit to check, and the math is correct. Okay, the simulation gives me 0.90 amps for the current through the battery. So this slide just has a picture of it all connected. This slide's what's going to go into your notes. Okay, so that's how you do the equivalent resistance for a mixed circuit. And after you've calculated equivalent resistance and the current through the battery, you can complete the circuit puzzle. Okay, so I'll show this in the other video as well. I'll complete these squares, but I filled in all the resistances for each of the components. I filled in the 21.1 ohm equivalent resistance that I just calculated. I fill in the 19 volt battery, and I fill in the 0.9 amps through the battery that I just calculated. And my job would be to figure out the rest of the blanks here. Okay, so I'll finish this off in the next video.